Hi, I'm Kai. I'm going to do the question 2 of hw5 for probability and stochastic processes. So the question 2, the f of xy is given. The first question, we need to draw the non-zero definition region of f of xy. So we know y is larger than or equal to 1 and x is between 1 divided by y and y. So we can draw the line y is equal to 1 and the line y is equal to x and y is equal to 1 over x. So the shape area would be the non-zero definition region of f of xy. The second question, find a so that f xy is a valid joint density function. We know if fxy is a valid joint density function, then the double integral of fxy will be 1, and d is the shape area. So we know for the area D, y is larger than 1 and x is between 1 over y and y. So for y, the lower bound will be 1 and the upper bound will be infinity. For x, the lower bound will be 1 over y and the upper bound will be y. So now we can calculate this integral first, and it will be 1 over 8 times the integral from 1 to the infinity, 2 times ln of y divided by y squared dy. And then we can move 2 here, and we move y squared here. So it will become negative 2 divided by 8 times the integral from 1 to infinity of ln of y dy to the power of negative 1. And then we can use the integration by parts. And the first term, we can rewrite this integral as ln of y times y to the power of negative 1, and y is from 1 to positive infinity, minus the integral from 1 to infinity y to the power of negative 1 times 1 over y dy. So the first term, the result will be 0, and for the second term, the result will be 1. So at last, we have 2 divided by a is equal to 1. So a is equal to 2. The question 3, find and draw the marginal density functions fx and fy. We know by first we can find fx. We know by definition fx is the integral of fxy dy. And the joint density function fxy is 1 divided by 2 times y squared times x. We note for the graph, when x is between 0 and 1, y will 1 is larger than or equal to 1 over x. So for y, the lower bound will be 1 over x, and the upper bound would be infinity. So we can calculate this integral. The final result will be 1/2. And if x is larger than 1 and y will be larger than x, so for the integral, the lower bound of y would be x, the upper bound will be infinity. So we can calculate this integral, and the final result will be 1 over 2 times x squared. For x is less than 0, the fx will be 0. And now we have fx, and then we can find fy. We know by definition fy is the integral of the joint density function of xy dx. So we know the shade in the shade area, y is larger than or equal to 1, and x is between 1 over wide and wide. So for the integral, the lower bound of x will be 1 divided by y, and the upper bound will be wide. So we can calculate this integral, and the final result will be ln of y divided by y squared. So now we have our marginal density functions fx, fy. Fx is 0 when x is less than 0, and it is 1/2 when x is between 0 and 1, and it is 1 over 2 times x squared when x is larger than 1. Fy will be 0 when y is less than 1, and it will be ln of y divided by y squared when y is larger than 1. The question 4, verify fx and fy are valid density functions. First, we can verify fx. The integral from minus infinity to infinity fx dx is the integral from 0 to 1 of 1/2 dx plus the integral from 1 to infinity 1 divided by 2 times x squared dx. And the first term will be 1/2, and the second term will be 1/2. So the integral of fx dx is 1, so it is a valid density function. So for fy, the integral of fy dy, the lower bound will be 1, and the upper bound will be past infinity. So we can calculate this integral, and the final result is 1. So fy is a valid density function.